Again, welcome everybody. Today we'll be solving Leetcode 1975 maximum matrix sum. In this problem, our goal is to maximize the summation of the elements of the matrix, and we're given a matrix size n by n, so it's a square matrix, and we're allowed to perform this operation where any two adjacent elements, we can multiply them by each of them by -1. So let's go over this example here that they give us. So let's look at this here. So they've highlighted -2 and -3. Since they're adjacent, we're allowed to multiply them by -1, and notice how they both become positive. Same thing over here. We're focused on this +1 and -1. Multiply this 1 by -1 and we get a -1. Multiply this -1 by -1, we get a +1. And now these two are neighbors or adjacent, and we perform the same operation and we make them both positive. Okay, so I think this problem's pretty straightforward to understand. Now the question becomes how to approach it. Now, one thing hopefully that's quite clear is that when you have a matrix and it has an even number of negative elements, we can convert every single element to a positive element. So let me write that down. When we have an odd number of negative elements, we can convert all elements to positive. Okay. Now in this scenario, notice how we have an odd number of negative elements. Now notice how we can convert an even number of them to positive values, but we'll always be left with one negative value. So let's write that down. When we have this should be an even, have an odd number of negative values or negative elements, the best we can do is reduce the number of negative elements to 1. So when we have an even number of negative elements, we can convert all elements to positive. Okay. When we have an odd number of negative elements, the best we can do is reduce the number of negative elements to 1. Okay. So let's go over this example here that I've contrived or made up. So here we have an odd number of negative elements. So let's, again, our ultimate goal is to maximize the matrix sum. So in our head, we should be thinking, well, we want to convert the negatives to positive. So we can look at these two elements here, and since they are neighbors, we can perform the provided operation that they've allowed. So we change the -3 to +3 and the +1 to -1. And now we can convert these two or perform the provided operation or allowed operation, and this becomes +1 and +5. And now this is the best we can do. We can't convert this negative to, or we can't make them all positive. We're left with one negative. Now our ultimate goal is to maximize the sum of all of the elements of the matrix. Now clearly it would be better if we if we have an odd number of negative elements, our goal should be to make sure or ensure that the smallest element, the smallest absolute value element is negative. So the absolute value of 1 and negative 2 is what, 1 and 2. So let's always focus on making the smallest absolute value element. Let's make that value negative. So that's basically going to be our strategy here. We'll try to maintain, as we loop through all the elements of the matrix, we'll try to figure out or maintain a minimum element, but the absolute value of it. So we'll try to find the smallest absolute value throughout as we loop through the matrix through each of the elements. And that's pretty much the entire problem right there. With these two statements, we'll try to keep that in mind as we loop through all the elements of the matrix. I think it'll be more clear as we solve the problem. So let's do that. So first thing we'll do is we'll have a total as we loop through the matrix. We'll keep a running total. We'll keep a running total of the minimum. And we want to know the number of negative elements. So currently the total is 0. The minimum element is, I don't know what it is. Let's just say it's, we'll just call it float. Negative infinity for now. Sorry, and negative 0. Let's take that back. The minimum element, we want to keep it small, so we'll just call it maximum. We'll do this here, the opposite. And now let's loop through every element of the matrix. So for row and m, for element in row. Now, if we see the element is negative, we'll do a little trick here, or not a trick, but we'll convert it to a positive for the moment. So we'll just say element times equals -1. And we'll keep it because we want to add this value to the total. And we want to update our number of negative values. So we'll say negative. Now I'm going to do a little bit of a trick here. Instead of just counting the number of negative elements, we just want to, I'm just going to use this XORs. So currently the value for negative is 0. When we see a negative value, we'll XOR it. So 0 XOR 1 will give us 1. If we see another negative element, then negative would be 1 at that time. 1 XOR with 1 would give you 0. So in essence, we've removed the necessity to figure out if there are an odd number of negative values or an even number of negative values by doing this little bit manipulation here. Now we'll add the value to the total. Total plus equals element. And that's essentially it. We can, that's all we need to do with the problem. Oh, we need to update the minimum. So the minimum should equal the minimum of the current minimum or the current element. Okay? And that's basically all we need to do. So now we need to return, so the total. Now here's where we need to figure out or be a little bit wise here. So all along we've been adding the positive version of the element to our sum. So in this case, if we had -1, we would have added +1 here to the total. Remember, because we converted it to a positive. So that means when we adjust our total, we need to keep that in mind. So we'll use 2 times the minimum. But remember, we only want to remove anything if there is an odd number of negatives. So because I have XORed negative with 0, 1, So negative could only be two values. It could only be 0 or 1. And luckily, and the way that we've situated it or set it up is that if there is an even number of negatives, negative will be 0. If there's an odd number of negatives, negative will be 1. So if there's an odd number of negatives, an odd number of negatives, this will be 1, and then this is perfectly fine to reduce it, the total, by this. If there's an even number of negative values, this will be 0, which means this doesn't exist, which means we're just simply returning the total. And that's it. So I'm checking the problem here just to make sure that that it works fine. And it looks like it does. Now let's submit it. Now, there we go. There is the problem somewhat straightforward once you recognize these two statements here. Again, the crux of the problem was to recognize that if we have an even number of negative elements, we can convert everything to a positive. If we have an odd number of negative values or elements, we can reduce the number of negative elements to 1. And at that point, we should be thinking, well, we can select any element to be that negative element. And we decided to choose the smallest of them, the smallest of the absolute values. I hope this makes sense. If this was in any way helpful or educational, give a like or subscribe. Other than that, have a great day. Cheers.